Initial value and boundary value problems of differential equation.
So, all right, class, today we want to look at the general solutions, the initial value and boundary value problems. The initial value and the boundary value problems. All right. Now, let's consider example. Y is equal to C1e minus 2x plus C2e 3x. Now, when you see the initial value problem, the initial value problem is when we are having an independent value which is the same in different conditions. We are having an independent value which is the same in different conditions. So now, with the initial value problem, it is an independent value which is same in different conditions. Okay, let me change my marker. So this one is dying. Which is same in what? In different conditions. But when you have the boundary value problem, it is an independent value which is different or which has been picked differently. So it is an independent value which is different in different conditions. So the initial value problem, they are same in different conditions, but the boundary value problems, they are different in different conditions. So for a typical example here, let's say you have y prime prime plus 2y, which is equal to e exponent x. And you have been given boundary of y of x is equal to 1. And when y prime of x is equal to what? Is equal to 2. So now this is a boundary. This is a value you have been given. And this particular value is an initial value. It's an initial value problem. It is not a boundary value problem. It is not a boundary value problem. Now what happens is that you have been given initial values. So y prime of x 1 and y prime of x is equal to 2. But you have been given what? As the same y of x. Same in what? In different conditions. Are you getting it? So now, okay, so that's y prime of x is also equal to 1. So they have been given what? In different what? Conditions. They have been given in different, as the same in what? In different conditions. You can also have another situation where you have the boundary value problem given differently in different what? Conditions. But with all this, what you have to know is that anytime you have been given the initial value problem or the boundary value problem, it helps you to find the arbitrary constant. So now you can say the IVP or the BVP helps to find the arbitrary constants. They help you to find the arbitrary constant. They help you to find the arbitrary constant. All right. So now, if that is the case, then we can go here and look at it. Let's take a typical example 1. So the example you have been given on the board, we said you have been given y is equal to c1 e of minus 2x plus c2 e of what? E of 3x. So this was the example we solved in the general solution earlier on. Yeah. And we said we should show that. The question said we should show that y of 0 is equal to 3 and y prime of 0 is equal to what? 4. So y of 0 is equal to 3 and y prime of 0 is equal to 3. Is equal to 4. So now this one is an initial value problem because they are what? They are same. They are all 0, 0. But in different what? Conditions. In the conditions of what? Y and what? And y prime. Alright. So now this also helps us find the constants to what? The C1 and the C2. So now how do we go about it? So now if y prime of 0 is equal to 3, then you can see over here that y here is 3, which is equal to if you put C1 E minus 2, so x is 0. So y prime of 0 simply means y prime of 0 simply means is equal to that. If x is 0, then y is what? Is 3. If x is 0, then y is what? Is 3. So the initial value have been given. Alright, so you get plus C2E3 0. So now you get E exponent 0, which is the same as 1. So you get 3 is equal to C1. Yet you get E exponent 0, which is the same as what? 1 plus what? C2. So the first boundary condition will give us this. The first initial value will give us what? This problem to solve. And the second one, if y prime not of 0 is equal to what? Is equal to 4. So how do we go about the y prime? We have to differentiate the equation. So y is equal to C1e minus 2x plus C2e 3x. So when you find the derivative y prime, you get what? Minus 2x. We get what? Minus 2 C1e of minus 2x plus 3 C2e of what? Of 3x. So now, he said if y prime is equal to 4, if x is equal to 0, then y prime is equal to 4. So therefore we get 4, which is equal to negative 2 C1 u of negative 2 times 0 plus 3C2 u of what? Sorry, u of 3 times what? 0. So now when you do this, what are you getting? Okay, let me come here. We get 4 is equal to negative 2C1 plus 3C what? C2. So now you are getting two equations. 3 is equal to C1 plus C2. And the next one is 4 is equal to negative 2C1 plus 3C2. Alright. So now you can solve it simultaneously. You can solve the two equations what? Simultaneously. Alright. And I don't have my calculator here, so I'd like you to solve it. I've not solved it though. So I'd like you to solve it simultaneously. Okay. Okay, but let's try it. So let's try and eliminate the C1 first. So let's multiply this one by 2. So we get 6. You can just use the calculator to point it out and you get it. 2C1 plus 2C2. So now, if you want to eliminate it, then this and this, you can eliminate this one by subtracting this from it. Adding, so if you add, you get 10, which is equal to 5C2. Alright, so the same thing, the 5C2, we can multiply equation 1, the same equation 1 by 2. Sorry, the same equation 1 by 5, and we compare it to this equation. So if you do that by 5, you get 15 is equal to 5C1. No. So that equation 2, sorry. You can get this equation. We're going to find how to eliminate the 2. Alright, so okay, so when you do this, you have the C2. So our C2 is equal to what? 10 divided by 5, which is what? Which is 2. Alright. So now we can put our C2 here and find our C1. Very simple. So we can have 3 is equal to C1 plus 2. So therefore our C1 is simply equal to 3 minus 2. And our C1 will give us 1. Okay. So that is it. So if you have our C1 as 1 and our C2 as 2, then the general equation now becomes what? Our y is equal to C1, which is 1. So 1 times what? 1 times e exponent negative 2x plus our C2 is what? Is 2 plus 2 times C2, sorry, 2 times e exponent what? 3x. And this will be what? The solution. Because we're given some initial what? Values. We're given some initial values. As time goes on, when you are solving the questions, you look at questions where you are given the boundary value problems. Thank you very much for joining and have a nice day.